Hello everyone, I welcome you all, and in this video we are going to discuss practice exercise 2.2 for its part B, because in the previous video we have converted that given vector A into its Cartesian system. Now here in this video we are going to convert that vector B into its Cartesian system. Now if you look out for that vector B, so that vector B is expressed in terms of the spherical form. Okay, so the thing is that we have to convert this spherical vector into its rectangular form. Okay, so for that purpose, we are going to need some expressions. So that expressions I am going to write it for you. Very firstly, we are going to write that given vector B in terms of its generalized form. So given vector B having the generalized form will be what? It will be like this one. So vector B having the components of along vector B along r, theta and phi direction. So this is the generalized form of that vector B in its spherical form. Okay, so b theta a theta, and this will be what? It will be b phi a phi cap. So we are going to assign some equation number to this one. So whatever is that given vector, so we are going to say it to be equation say for equation number 1, and that generalized form we are going to say it as equation number 2. Now, what are the necessary expressions that we are going to make use of? So, here in this case, we are going to make use of that r, theta, and phi, because for spherical system, we have for spherical systems we have the values of that r, theta, and phi. So, what is that r value? So, r is nothing but square root of x square plus y square plus z square, then theta. So theta have been expressed like this one, which is nothing but cos inverse of z upon r, or it can be also written in terms of that tan inverse of square root of x square plus y square upon z, and that phi. So phi is constant for your spherical as well as cylindrical system, which is tan inverse of y upon x. Okay, so if you have the values of that r, theta and phi, so you can skip the part of this video, or else I am going to derive it for you. So what is that theta? So if you look out, so very firstly we are going to write that theta in terms of its sine theta and cos theta value. So we are going to refer this equation for now. Okay, so what theta value we have in terms of cos? So that theta is cos inverse of z upon r, that we have already written. So it can be expressed like this one. So that is cos of theta z upon r. And what is that r value we have? So r, you can refer this value over here. So you can write that cos theta is nothing but what? Cos theta will be z upon square root of x square plus y square plus z square. So this is the cos theta value that we have from this expression. Now next is we are going to find out the what is the value of that sine of theta. Okay, so for that value we are going to make use of this equation now. So again we have that theta as tan inverse of square root of x square plus y square upon z. So it can be written like this one, that tan of theta will be square root of x square plus y square upon z, which is sine theta upon cos theta. Again, this term will be as it is for now, x square plus y square upon z. And now we have the value for this cos of theta. Okay, so we are going to put that value like this one, that sine of theta will be square root of x square plus y square upon z multiplied by this cos theta over here, and now put the value of that cos of theta. So that will be what now? Square root of x square plus y square upon z multiplied by cos theta is what we have, that is z upon square root of x square plus y square plus z square. Okay, now this z over here and this z over here, it will get cancel out. So what is the value of sine theta? So we are left with that sine of theta, which is equals to square root of x square plus y square divided by square root of x square plus y square plus z square. Okay, now we have the value of that sine of theta over here, and we have the value of the cos of theta. See, whatever I am writing in black ink is not expected from you to write in your examination. These derivations are not important for your theoretical point of view. The thing is that it is for your understanding purpose. So it is expected that you should know the values of this sine of theta and this cos of theta, so that directly you can go with the numerical. Okay. Now next is we have to write for that value of that sine of phi and cos of phi. Okay. So sine phi. So again I am writing it for you in its black ink. Okay. So that sine of phi is what we have from cylindrical system. So we have that sine of phi is equals to y upon rho, which is equals to what now? So this sine of phi will be y upon square root of x square plus y square. So this is the value for that sine of phi. And then next is what? We have the cos phi. So cos phi is again x upon rho. This is from your cylindrical coordinate system. So we have that cos phi as x upon square root of x square plus y square. Okay, so these are some expressions that we are going to make use while solving this numerical. So it is expected that you should directly write these values of sine theta, cos theta, and sine phi and cos phi in your theory exam, not about this derivation. Okay, so put these values of that sine theta, cos theta like this, and sine phi and cos phi in your equation 1, which is equation 1. So this is your equation 1. Okay, so we are going to put that values of that sine theta, cos theta, sine phi and cos phi in your equation number 1. Okay, so this is your equation 1, which basically have that r component and sine theta component only. So we need to put the values of that r and sine theta only. Okay, so what is that given vector b? So this is your given vector b, which is r square ar cap plus sine theta a phi cap, sorry, this is a phi, not a theta. So this is what? A phi. Okay, now what is that r square? So r square, that we have already written, that r is nothing but what? Square root of x square plus y square plus z square. So that r square will be what now? X square plus y square plus z square ar cap plus sine theta, that we have already derived. So which is what? X square plus y square, that to taken in the square root, divided by square root of x square plus y square plus z square. Having component along phi direction. Okay, so assign equation to this one. So I guess this is equation 3, and this is your vector b, which is partially in Cartesian system and partially in the spherical system. Why partially? Because we have the spherical unit vectors like this one, ar and a phi over there, and that is along the component of x, y, and z. Okay, so we have to convert this vector b in its Cartesian system. So for that purpose, we are going to make use of the transformation table. But before that, very firstly, we are going to generalize form of that vector b in its Cartesian system. So that will be what now? So vector b in Cartesian system can be expressed like this one. So what will be generalized form of that vector b? So it will be vector b having component along x direction, having unit vector along x direction, component along y direction, having unit vector along y direction, and component along z direction, having unit vector in the z direction. So I'm going to say it to be equation 4. Now we are going to make use of the vector transformation table in order to convert that vector into its Cartesian form. Okay, so here in this case we are going to make use of equation 3 and 4. So if you are going to compare equation 3 and 4, so what is that bx that we have over here? So bx is nothing but that will be your given vector. Okay, so I'm going to write it for you. So bx component will be what now? Your given vector b having component along x direction. Okay, so what is that vector b that we have? So we have that vector b from equation 3 as x square plus y square plus z square ar cap plus square root of x square plus y square divided by square root of x square plus y square plus z square having component along the phi direction, and then it has to be multiplied with what? Unit vector along x direction. Okay, so multiply that one. So that will be what now? X square plus y square plus z square. It will be as it is. Now the dot product in between that AR and AX over here. So dot product in between that AR and AX. So now you can refer this vector transformation table. So dot product in between that AR and X will be what now? Sin theta cos phi. So this term will be what now? Sin theta cos phi plus square root of x square plus y square divided by square root of x square plus y square plus z square. Now the dot product in between that a phi and ax. So dot product in between a phi and ax. So this is what we have, a phi over here, and this is again your ax. So dot product in between that ax and a phi is what? Minus of sin phi. So this will be what now? So that is minus of sin phi. Okay, fine. Now we are going to put the values of that sin theta and cos phi that we have found earlier. So what is that values of that sin theta and cos phi? So this very first bracket, it will be as it is, square root of x square plus y square plus z square. It will be as it is. Now sin of theta. So sin theta that we have found, which is to be square root of x square plus y square divided by square root of x square plus y square plus z square. Now cos phi. So cos phi, where we have that to be x upon square root of x square plus y square. Okay. Now this minus sign, it will come over here. So that will be minus of square root of x square plus y square divided by square root of x square plus y square plus z square. Now we have the value of that sine phi. So what is that value of sine phi that we have found earlier? So that is y upon square root of x square plus y square. Okay. Now we have these values over here. So this square root of x square plus y square and this square root of x square plus y square, it will get cancelled out. Here in this case, it will get cancelled out over here. So we are left with values which is, and you can take the denominator common, which is what? 1 upon square root of x square plus y square plus z square. So I'm going to write it over here, which is we have taken common out of the bracket. So that will be square root of x square plus y square plus z square that we have taken common. And what is left now? So we are left with this x into x square plus y square plus z square minus this y. Okay, so this is the value for Vx only, or you can say the component of vector B along x direction. So assign some equation to this one. So I'm going to say it to be the A. Okay. Now in similar fashion, we are going to find out what is that Vy and that Vz. Okay, so we have equation 3 and equation 4, and we have that vector transformation table. Now we are going to find out what is that Vy. Okay, so this is what we have, that By to be what? Given vector B having the dot product with Ay. Okay, now what is that vector B that we have from equation 3, which is x square plus y square plus z square ar cap plus square root of x square plus y square divided by square root of x square plus y square plus z square having a phi component over here, and we have to multiply, or we have to take its dot product with respect to what now? With respect to Ay. Okay, so we are going to take that dot product. So we have that square root, sorry, not square root, x square plus y square plus z square. Now the dot product in between that AR and AY. Dot product in between that AR and AY. So dot product in between that AR. So this is what we have, AR and AY over here. So what is that? Sin theta, sin phi. So this term will be what now? Sin theta, sin phi plus square root of x square plus y square divided by square root of x square plus y square plus z square. Now we have the dot product in between that a phi and ay. So dot product in between this ay over here, and then we have a phi. So dot product in between ay and a phi is what? We have that to be the cos of phi. Now we are going to put the values of that sin theta, sin phi and cos phi in order to get our answer. So what is left? So we have this very first bracket, which is as it is, x square plus y square plus z square sin theta. So we have that sin theta to be what? Square root of x square plus y square divided by square root of x square plus y square plus z square. Then next is we have sin phi. So sin phi we have value to be what? Y upon square root of x square plus y square plus this. bracket will be as it is. So square root of x square plus y square, it will be as it is, divided by square root of x square plus y square plus z square cos of phi. So what is that value for that cos phi? We have that to be x upon square root of x square plus y square. Okay. Now this square root of x square plus y square and this square root of x square plus y square, it will get cancelled out. It will also get cancelled out. Okay. So what is left? So we are left with this value, which is this y. Now again, you can take this square root of x square plus y square plus z square as common term. So write it as 1 divided by square root of x square plus y square plus z square. And this y into this x square plus y square plus z square plus, now here in this case we are left with x value only. Okay, so this is the value for Vy, and say it for equation B. Okay, now in similar fashion we are going to find out what is the value for that Vz. So again we are going to make use of equation 3 and 4 along with that vector transformation table, and we are going to rewrite for your Bz value. So what is that Bz? So Bz will be your given vector B, which will have the dot product with respect to the unit vector along z direction. Okay, so we are going to write for that vector B. So what is that vector B? Which is x square plus y square plus z square ar cap plus, sorry, something happened. Okay, sorry. Yes. This will be x square plus y square divided by square root of x square plus y square plus z square, having a phi component over here. So this is your given vector B. Now we have to take its dot product with respect to AZ. Now the dot product in between that AR and AZ. So dot product in between that AR over here and AZ over here. So that is what? Cos of theta. So the dot product in between that AR and AZ. So this will be as it is, x square plus y square plus z square, and the dot product in between that AR and AZ is what? Cos of theta. Okay. Now the dot product in between phi and z. So dot product in between that phi and z. So which is 0. So I am not going to write any value for this since we have that value to be 0. So this is the Vz, and now we are going to put the value of that cos of theta, keeping this very first term as it is. So that is x square plus y square plus z square, and that cos theta value we have to be z upon square root of x square plus y square plus z square. Again, you can say you can take 1 upon square root of this x square plus y square plus z square as a common value from this one. Okay, so that it will be good to write you. So, and what is left? So we are left with z within that bracket x square plus y square plus z square. Okay, say this to be equation C. Now we are going to combine that equation A, B and C, and we are going to put that A, B, and C in your equation 4 that we have already written. Okay, now we will look out. We have this equation C for your Bz. We have equation B for By. We have equation A. Yes, we have equation A for a value of that Bx. Okay, so we are going to make use of this equation A, B, and this C along with equation number 4. So we have this equation number 4 over here, and we are going to put the values of that Bx, this Bx, By, and Bz only to get the value of that vector B. So we can rewrite as that vector B is nothing but your 1 upon square root of x square plus y square plus z square, and within that bracket you can write as x square root of x square plus y square plus z square minus y ax cap plus y x square plus y square plus z square plus x. This is for your y component, and plus this z component that we have found just now. So that will be x square plus y square plus z square along z direction. Okay, so this is how we have converted your given vector B from its spherical form into its Cartesian form. Okay, so if you appreciate my efforts, you just hit the like button. If you have anything to tell me, if you have any feedback, so please write it in the comment box. Okay, thank you.